So we're going to continue on with our lessons in Tools of Geometry in your first unit, and today we're going to talk about measuring segments. Okay, so two big important things to talk about. We're going to talk about the ruler postulate, and we're going to talk about the segment addition postulate. Okay, so ruler postulate says that the points of a line can be put into a one-to-one correspondence with the real numbers so that the distance between any 2 points is the absolute value of the difference of the corresponding numbers. Okay? Now, it seems kind of strange to think about just on paper, but I promise when we do the example in a minute, you'll be like, oh, it's that easy? Like, yes, it's that easy. And also something important here that if two segments have the same exact length, we say they are congruent. Probably heard that word before. And the symbol for congruency is an equal sign with a squiggle or a tilde, I would call it on top, okay? All right, let's use this ruler postulate. So we're going to find the length of AB and BC. So AB, we want to find where A is at. A is at -8. So inside my absolute value, I'm going to put the -8 because that's where A is at. Always subtract no matter what. And then wherever B is at. B is at -5, so I'm going to do minus -5. Now that inside simplifies to -8 plus 5, which would be the absolute value of -3, and we all know that is 3. Okay, let's do BC. B is at -5. Subtract where C is at. C is at -2. That simplifies to -3, and so we get 3 again. Are A, B, and BC congruent? We say yes. If AB equals BC, this implies that the segment, oops, you can't read that where I wrote it, hang on. Implies that segment AB is congruent to segment BC. Okay. I don't know if we've said this thus far in class, but I want you to see the difference. If you don't put the segment bar on top of this, you're talking about the length of that segment, its measurement, okay? If you do put the segment bar on top, you're actually talking about the segment itself, the name of it, all right? That's all ruler postulate is, okay? It's that easy. Or make it even simpler. You're trying to find the length from A to B, so find A and B. Just count the distance. 1, 2, 3. That easy. Or BC is 1, 2, 3. There you go. So you can either do this absolute value thing, which is not hard, or you can literally just count. Okay, whichever one works for you. All right, segment addition postulate. So this is kind of convenient and helpful because, and it's kind of common sense when you think about it. So the segment addition postulate says if 3 points A, B, and C are collinear and B is between A and C, so look at our picture here, A, B, C are collinear, they're all on the same line, B is in the middle, then we say that the measure of AB plus the measure of BC equals the measure of AC. Okay? And here's how I like to think about it. I would call AB, I would call that a piece. So I would like to think of it as a piece plus another piece equals the whole segment. That's how my brain thinks about it. I don't know if y'all would think that way, but that's what I think about it. So if I add the pieces up, it should equal the whole length. Okay. So let's see this in action. Okay. As far as like a basic step. So R, S, and T, we've got R, S, S, T are the pieces, and then R, T is the whole thing. Okay. They tell us that R, S is 15 and S, T is 9. So let's label that 15 and 9. They want RT. RT is the whole thing. So if I come over here and like write out the segment addition postulate, I would say RS plus ST equals RT. And then we're going to plug in what we know. RS was 15, ST was 9. We're trying to find RT. And then we would simply add those two numbers up, so we would get that RT is 24. And that's really all there is. Okay? Now, next problem. This top here actually goes with the picture on the previous page, so I kind of wish I printed this off one-sided so it wouldn't be so much flipping, but anyway. So now they told us that ST is 15 and RT is 40. Remember, RT is the whole thing. So let me flip back real quick just so you can see the picture. This time they told us S to T is 15 and RT, the whole length, is 40. So it's a little bit of a different problem now. So let me flip back over. Straighten my pages up. All right, so I'm going to write this out. RS plus ST equals RT. I don't know RS, but I know ST is 15, and this is 40. And so kind of like we're solving like an equation. We want to find RS, so we're going to subtract the 15. So RS here is 40, subtract 15, which when you do that math, it should be 25. All right. That's it. It's kind of simple. And now to step it up, we're going to talk about algebra with this a little bit, all right? So again, we're going to have RS plus ST equals RT. But this time we have expressions to plug in, so we're going to plug those in. So we're going to have 3x plus 1 plus 2x minus 2. So RS is this whole piece, and then ST is this whole piece. That's going to equal the whole length of RT, which is 64. All right. We need to combine like terms, so 3x and 2x gives me 5x. 1 subtract 2 gives me negative 1 minus 1 equals 64. Now we solve, so I'm going to add 1. 5x equals 65. Divide 5 and divide 5. So x should be 13. Okay? Now the question says they want you to find RS and ST. Okay? They both have an x in them, so we have to use this x we just found. So RS is going to be 3 times 13 plus 1, which when you evaluate that, that's going to be 40. ST is going to be 2 times 13, subtract 2. When you evaluate that, that's going to be 24. That's it. That's all you do. Okay. Now, in addition with our segment addition postulate, we have a kind of special case with it where that middle point, that point in between our endpoints actually lies in the direct middle of the segment. And when that happens, we call it the midpoint. Okay? So a midpoint is a point that divides a segment into two congruent segments. You can kind of think about it as it divides the whole segment into two equal halves. Okay? And a midpoint is said to bisect the segment. And as I kind of said earlier, bisect kind of means to cut in half. Okay? So I want you to look at this picture for a minute before we start working. So we're saying that T is the midpoint of the segment PQ. And I can say that because I've got these little dashes right here. Okay? Anytime in geometry, when you see those dashes, or you might have a set of 2 dashes or a set of 3 dashes, that means that those things are the exact same length. It means they're congruent. In this specific instance, this is your clue that this segment has been bisected and T is the midpoint because it's smack dab in the middle. Okay? All right, now solving a midpoint problem is a little bit different than segment addition postulate, but it's not that bad. So because this point T is the midpoint, we know that the length from P to T is the same length as from T to Q. So these expressions they gave me, I'm going to set those equal to each other. So PT is equal to TQ. So then 5x plus 23. Oh, not 23. Sorry. I don't know where I got that from. Plus 3 equals 7x minus 9. Okay, now when you have variables on both sides, remember that you want all your variables on one side and all your other stuff on the other side. My personal preference is I like to keep my variable positive if I can. And so to do that, it will almost always be you want to subtract the smaller x first, no matter what side it's on. Okay, 5 is smaller than 7, so I'm going to subtract that x first. That will give me 2x minus 9. Now I'm going to add the 9. That gives me 12 equals 2x. Divide 2. So x is going to equal 6. Okay? Now, I have to use this value of x to figure out the lengths of these segments, all right? So PT is going to be 5 times our x plus 3. And when you evaluate that, you get 33. TQ is going to be 7 times our x value minus 9. When you evaluate that, that's also 33. And then you can think about using your segment addition postulate here. We know a piece of the segment. We know another piece of the segment. We want the whole thing now. So 33 plus 33 gives us the whole length of 66. Because PT plus TQ equals PQ. Okay? All right, let's do it again. Same setup, we see tick marks, so we're dealing with a midpoint. So whatever PT is equals to whatever TQ is, so I'm going to set those equal. 7x minus 24 equals 6x minus 2. always start at the smallest x, so I'm going to subtract the 6x. Gives me x minus 24 equals negative 2. Add 24. So x is 22. Now I'm going to use this x. So 7 times 22 minus 24. You type that in some calculator, you'll get 130. 6 times 22 minus 2. You type that in, you can also get 130. All right. And then on the very last page, because it would not fit no matter how much I tried to make it work, we have PQ. So again, we're going to use the segment addition postulate with these two pieces we found. So we're going to say that PT plus, whoops, wrong letter. Oh, you can't see what I'm writing. That's funny. Plus TQ. My handwriting is atrocious. I don't know what is wrong with me. PT plus TQ equals PQ. And so both these pieces were 130. 130 plus 130 gives us 260. All right. That's all there is for measuring segments, so it's real easy, I think, relatively. You've got your ruler postulate. You have your segment addition postulate. A piece plus a piece equals a whole. And then you have a midpoint where your two pieces are equal to each other now. Okay? So please watch this video before you start your homework. And that's all I have.